I'm back with Leon's substitute engine, and we were talking about traction tires the other day, and I thought I'd give you a little brief on some of this stuff because there are differences and you need to be aware of them if you're having traction problems. The steel wheels or metal on the track wheels are not great for traction, especially if you have an Atlantic or a Pacific with a long load. You'll spin on hills and going up inclines and sometimes turns. So the idea is to put a rubber ring around the tire of the driven wheel. On the Atlantics, sometimes we do the front wheel to prevent the rear end from lifting the front end because it's such a short wheelbase. So you may on an Atlantic put the traction tire in the front and all the Pacific and Northerns on the back. Just seems to be a convention. Okay. Now, I learned early on there's two types of traction tires. This is a thick traction tire, and this is a newer replacement tire that is thin. The thin one is used to put traction tires on the metal rim tires that did not have traction tires to begin with. Because it's so thin, it doesn't take that much of the guide lip off of the wheel, so you can stay on the track, still drive around. If you put this big thick wheel on here, you would be risking running off the track. The reason there is this big thick wheel is there are some wheels, and Leon has one here, is a metal, and the rim, as you can see visually, his rim overall is bigger than the standard flyer rim. And when you have that deep rim, it's designed for the thicker traction tire or the traction bands or whatnot. I've also found on older one, molded plastic wheel also comes with the thicker one, and it also has that wider rim that can handle that thicker one. So check your diameters before you order. I've ordered these by mistake. I needed these. I had to reorder. So now I have a supply of these, which I'm not sure I'm going to use, but that's the way it is. Now, putting them on is a little tricky. They're elastic, so they will stretch, but you're going to have to use something strong. I use a small screwdriver with a very narrow tip on it, and I hold one end down and I just walk it around the rim until it's perfectly sealed. Then I come back around with my a little broken stick that I have, and all I do is I prise that lip out just a little bit, and then I put a drop of super glue into that crevice that I've opened up, and then I push it back down and I smooth it over with my hand. I don't care, it's fine. And what I like to do is I start where there's the screw attachment for the linkage or the nub, and I just go every 90 degrees. So I put a drop here, I put a drop here, I put a drop here, and I put a drop here, and I wipe it down and I let it cure for an hour or two, and then I test it out. The other thing I do right away, though, is I try to put it up on something where I can see the wheel and verify that the wheels are okay. And what I look for are they square and is the rubber consistent. Sometimes you can get sort of like a wave, like it's in too tight or out too far. You want to make sure you've got balanced placement of the rubber tire and that it looks smooth and all that. So that's what I use to test that, make sure that's in good shape. Then I just finished this guy and I put him on the rubber tire on the rolling road, Andy's rolling road with traction tires. And the fun part is it's quieter and it's more stable. It still has a little bobble in it. I'm not sure what that is, but there always seems to be a bobble. In any case, it's much quieter with that wheel on there. And it's not walking across the table. And if the train itself is quieter, all you hear is that tiny electric motor screaming for mercy. Not really. It's screaming in joy because it's let loose. It's going out, full out. 17.7 volts. That's pretty nice, pretty stable. Now, I did do hot rods in the old days, so I like to just blip the throttle, we used to call it. And I'll do that with the overload on the amps set to high, so I don't limit the amperage at all. So here I am at 5 volts at 0.7, so I'm going to blip it. It blips up between 2 and 3 amps just for a moment, but that's me being mean. If I stick it to 17, it never goes over 1. Well, okay, I lied. 1.6. Okay, it stays down. You know, you really can't overload this thing. It's going to be 1 amp, typically 1.5, maybe 2 maximum with a heavy load. But there it is. Traction tires applied. They're staying on. They're on the rolling road. This thing could pull 12 cars, heavy weights, passenger cars. It could pull the load. I'm not worried about it. Okay. So the next step is we've got his new re-engineered lid or adapter for the switches. So I'm going to mount the switches on here, and I'm going to adjust them and make sure they're perfect. Then I'm going to take these wires. No, I'm not going to take these wires. Then I'm going to, I got to get his smoke ready. I got to shorten that up or find one. So I do the smoke. So I'm going to do the motor, the switches, the smoke. Then we'll do the motor control board. I mean the puff and chuck control board. He has one started, okay? Then we'll work on the tender, and I got a new tender, and I do have a new 6-wheel truck I'm working on. I may do a prototype first, get you a peek at that. And you know, we're always learning things and sharing with you, or try to in a way, and sometimes I may not do a great job of that, but here's another thing on this bushing thing. Where here's a chassis that has bushings in it, okay? And there you see Leon's without bushings, right? Now this guy had bushings, and when you look through there, you'll notice there's a big gap for the drive gear, okay? And the bushing is in 2 halves, 1 half on this side, 1 half on this side. These bushings, if you look through, they're solid one piece. So they look like this. They're just driven in, boom, boom. So if his had bushings, I could push these in, and I can show you. I'll take this apart for a moment. There we go. I'll just use this. Oh, I touched something. Don't do that. Okay, you stay here. This is I think this is the thick side. Let's see. Yeah. So there's a wide and a thin. But see, I'm sorry. See, this one has movement too. If I just come back, you dog. Oh, I can't believe it. I've pushed it in, and now I can't get it out. Okay, there it is. Holy cow. Okay, here we go. There's a little bit of movement there. It's not too bad, but it does have some wear. Now, when I do this to good old Leon's engine, I get that in there. Oh, my phone is slipping. Sorry, gang. What did I do? Flip that over in my hand? I must have. Okay. So when I do it to his, you'll see. You won't see. There you'll see. Quite a bit of movement. That bushing is, that area that has supposed to be a bushing is worn. And the other thing that you learn when you do these and take them apart, the drive shaft is very unique. It has an oversized area right here, oversized, and there's a bushing made for it, just for that oversized end. See that? Fits it nice, snug. If you put it on the wrong side, it will be real wobbly, and it won't work right. So you have to be careful that you put these on the right side. Not good. Okay. So there's a thick and thin side. Now you say, wow, why did I make it that way? Well, they had to put this gear in, right? And this gear had to be clamped on somehow. And they wanted a way of orientating and making sure everything was fine. They could fit it in there. They had to get these splines in. So they set those splines in through the thick one. Then you go into the thicker of the bushing. And now you got the same size tire on both ends, but you can assemble this smoothly. And the bigger area allows these neural marks in the center to go through the hole, and the neural marks are what hold this gear in place. When it's pressed onto those, it won't move, it won't rotate, it won't slide, okay? So this is how they decided to assemble this. Some of the newer engines, you'll see they're cut right here, or they're cut just above that. And this is a plate that you can take off. Some of the Flyer engines are that way in the late 50s, 60s, early 60s. Some of the Franklins are that way. So you can take that plate off and you just lift out everything. American Models does it that way too. And then the bushings are all assembled on the same shaft, but you just set them in and they're locked in either the shape, a square, or a groove or something that holds the bearing in place. And the wheels and everything are all fitted already. A couple of ways that they do that. This is what they have up in the front. They have a solid bushing that's pressed in and a solid shaft. So it's a lot simpler if you don't have the drive. And here's how these are done in some cases. There's a relief on the outside. You have to watch that because it might need to be countered or taken off. As you can see, this is flat. Now, look at this other side. It's flat. What happened? If you think about it, the metal rim was rubbing against the chassis. Now, the metal rim is touching the track. The track's hot. That could be arcing. It may have been arcing the whole time it was alive. The way this happens is this wears, but this really is not worn. It's scratched, but it's not worn. This hub, there is a hub on here, and if you look down the side, you can see it. It sticks out the slightest amount. If that hub gets worn flat, then this rim can touch. So when you take your engines down and do the inspection visually, this is what you're looking for. You wiggle things, you move them around. You do more than just clean them and oil them. You have to make sure, because if your wheels get loose, it only gets worse. And you can repair them. It's not that bad. Like on this one, we can knock those bushings out and press in the new ones and then put in the axle and gear back in, and we're all set. And the chassis is rebuilt, basically. It's all new and ready to go. And you can replace this front bushing here. In this case, with Leon's, we already replaced it with a ball bearing. And we're doing ball bearings in the other, brush holder too. That's why that engine is so smooth. So the bushings are a little tricky, different sizes. The drive axle is the tricky one because it has the gear. The wheels are all the same, but you got to watch the rim diameter to determine what kind of rubber traction device you need. And then if you get bushings, you make sure you either get the two-piece or the one-piece, depending on which one you need, or if you need. Usually we'll do them all at once. If one's worn, the others are, let's just update it right now. Boom. Push them all out, push in new ones, reassemble it. Bada boom. Okay. I have a couple wheel pullers. This is the one I got from Brain Freeze. I got it from the guy in Rhode Island. Oh God. Anyway, it's a train store up there. I forget. Long Island Lines. No, that's not it. Rhode Island Lines. No, that's not it. Anyway, you can get this from some suppliers. I don't really like it because these things can just fall right off, and they always do, and they rotate, and this is too thick, and la. This is one I inherited from a very dear friend. He was the older brother of a good buddy who had Lionel. So this is used for Lionel, but I've modified this pin here so I can use this to press off and on, and I've ground this down. You can see he actually ground that down so you could get behind the wheel in some of these and pull that off, and it works quite well. I'm sure it was expensive in its day. So wheel pullers are pretty useful tools to keep you from going bananas with screwdrivers and pry bars and whatnot. Bushings, fittings. As I assembled his engine and I put on the traction tires, and then I'm fitting the backlash. Let me unhook this. Just one more little thing that I find useful for folks sometimes. To check the backlash, you can pull the wheel down with your thumb, and you can almost create an air gap. Maybe not in this case, not quite, but then you push it forward and you'll feel it move a little bit, or you'll see it move. This moves a tiny bit. This has about less than half a thousandth of clearance. I've got it kind of tight, but I might want to take a little more out of it. But in any case, this is how you check your backlash. You want to have some movement. You're going to have some movement between the gears, but you also need to make sure that armature is free to move a little bit back and forth, a little bit. That may be a little too tight. The other test then, once you have established that, is to spin this and make sure that you can spin it nice and free. That it's no binding, it's not grabbing anything, and you can just kind of wiggle it back and forth and it's nice and free. And then the other thing is, if you have rolling road, if you don't have rolling road, get it. They're really handy. But also, you can listen to it and watch it. And if it's hopping around and vibrating and acting crazy, get down on it. Look at the wheels. Look and make sure they're square. Sometimes they're doing this to you, this wiggle woggle thing. Out around. I've had to round wheels before. It's all kinds of things can go goofy with these. They're toys. They're made in the 40s and 50s. So you tune them up. But the most rewarding thing for me is when I have it together and I hook it up to this was a DC power supply, because that's a DC motor now. It would not run on AC. And I turn this on. You get it around 10 volts, 11 volts. It is just steady eddy, smooth, strong. Just feels good, acts good, falls apart. Occasionally you want to tighten the screws when you do testing. Make sure things don't fly off while you're making a video. It's awfully embarrassing. At any rate, the wheels are working. Okay. Don't worry, Leon, I'll put it back together. All right, I pushed it too far. Okay. That'll do it for now. Now, I'm going to finish his engine, put on the smoke. I'll come back when it's smoking. How's that? Then I'm going to work on his tender. I got a new design for the trucks and the plate. Everything bolts on. It's great. We're making excellent progress on finishing one of the first complete next generation S gauge designs. Pretty cool. Later.